Page 6 of functions. Find the domain and range for each of the following functions. So let's look at A. Remember, this notation here is just trying to get used to another notation, which is the same as this, 2x minus 1. Okay? So let's figure out the domain and range for this. Now, this is just a line. So if you can imagine any line, except for a vertical line, of course, the domain and the range are going to both be all real numbers. Okay. What about D? This looks kind of weird, but it's just a horizontal line. If it's a horizontal line and the height of the line is 3. So again, all real numbers. Oh, I'm sorry, not all real numbers. The domain is all real numbers, but look at the range. The range is only at y equals 3. Very small range. Okay, and now we're going to do D. 1 over 1 plus x, or 1 over x plus 1. So x plus 1 cannot be 0. That would be bad, right? So let's see, when is x plus 1 equal to 0? Well, when x equals negative 1. We're going to subtract negative 1 from both sides. So what's our domain? Our domain is going to be x is all real numbers except x is not equal to negative 1. Let's talk about finding the range of this function. This is a little bit tricky because we haven't really talked about graphing hyperbolas yet. And this is a hyperbola. So I know you've done it in the past. So let's use the calculator for this. And the way you graph it is you go to y equals and you put the function into y equals and then you graph. To get a good close-up of that, go into zoom standard, which is option 6. And then when you graph it, you can see that, okay, all the x values are possible except for, and there's a value right here, which we already determined as negative 1, right? The other thing is we can see that the y values pretty much can be any number except for there seems to be a number right here in the middle that it cannot be, and that happens to be 0, right? You can never actually reach y equals 0 here. There's no value of x you can find that would make y equal to 0. So the range in this case would be y is all real numbers except y is not equal to 0. Okay. Oops. All right. Let's see. What about this function here? So E, we have to be careful because it's got two things. One is it has a square root function, so that automatically means the domain does only exist for x is greater than or equal to 0. But then if we look at it again, it's got square root of x in the denominator. The denominator can never be 0. So now we need to look at that and say, hey, x cannot be 0. So actually x can only be greater than 0. All right. Oh, what about y? Y can be, looks like any negative number. If you can put in x values from very close to 0 to infinity, you're going to get pretty much any negative number. You're never going to be able to actually get to 0. So you would say y is less than 0 for the range. Okay. All right. Use technology to help sketch graphs of the following function. All right, so I already showed you how to graph things with y equals, and the instructions are written also here. To find the minimum or maximum function, you can use second calc and min and max. Okay, so we're going to graph these functions using the calculator. So we're going to have square root of x minus 2. So we'll put square root of x minus 2. And then we'll graph it. And it looks kind of like that. We can see that it starts at x equals 2, and then it goes up like that. Okay. If you want to get some exact points, which is always a good idea, you go to second table, And then, oh my god, look where it's at. I need to go all the way back to 0 here. So, and then you can just pick out like 2 or 3 nice points, whole number points if possible. It'll make your life easier. So we'll start with 0, 0. Oh, it doesn't exist at 0, 0, of course, right? It starts at 2. So at 2, 0 it starts, and then the next number would be like 3, 1. So 3, 1 would be about there. And then like 6, 2. 6, 2 is another one. 1, 2, 3, 4, 5, 6. 6, 2 is about there. Okay. You can see that you could have graphed this just by putting, making a little table and say, oh, like I'm going to put in 2, I get 0. I'm going to put in 3, I get square root of 1. I'm going to put 6, I'm going to get 2, etc. You can like do that also, but we're trying to learn how to use a calculator too. So we're going to now do this next function, which would be 4 minus x. This is going to do something weird because we're putting a negative x here. Interesting. Now it looks like reversed. Okay, so it appears to cross at 0, 2, and it lands at about 4, 0. Looks kind of like that, right? So this is A, this is C. What about E? X squared plus 4. X squared plus 4. X squared plus 4. Okay, no surprise there. Well, I guess it is kind of a surprise. It's like a parabola with a square root. So it looks like it crosses at 0, 2. And you can kind of see that just from the hash marks on the line, right? You don't even have to like go into graph if you don't want to. What about G? Oh, we already did that one. 5x minus 3x squared. 5x minus 3x squared. This is going to be a parabola, right? So the vertex appears to be at about 1, 2 or 2, 2. We can't really tell, so let's look at the table to see where the vertex is. Oh, it's kind of in a weird place. So we'll just graph like these, the points that we can see. So 0, 0 is a point, 1, 2 is a point, 2, negative 2 is a point, negative 1, negative 8. Okay, so it's like, it looks kind of like that. Okay. And like if you want to see where the vertex is, how would you do that? You would use second Calc Max, right? So let's do that. Second Calc Max. So we have to use this function to find it because, I mean, like we could use, of course, the algebra we just reviewed in chapter 1, but so the max is 0.833 to 0.08, okay? So the max here is 0.833 and the y value is 2.08. Not exactly, but okay. I. X plus 4 divided by x minus 2. X plus 4 divided by x minus 2. Graph. Hyperbola. Okay, and I can't really see where the asymptote is, so I'm going to do second table. The error means asymptote. At x equals 2, y does not exist. So x equals 2, I'm going to draw the asymptote in a blue line because it's kind of hard to do dotted lines with my editor. So 2, okay, this is I, right? And then where do I have a horizontal asymptote? You can kind of see the horizontal asymptote by like going off to the top or the bottom. You can see that it is approaching a certain number. It looks like it's approaching maybe 1. Okay, so it's going to the left. It's approaching 1. When you go to the right, it looks like it might be approaching 1. So it approaches 1 from the top. And so when you go to the right, it approaches 1 from the top. And when you go to the left, it approaches 1 from the bottom. Okay. All right, and then K. That's kind of a mess. But that's the good thing about the calculator. The calculator is not intimidated by complex equations. Not like humans. 3x minus 9 divided by x squared minus x minus 2. I graph it. Oh, that's pretty wild. Okay, and let's see where the asymptotes are by going to second table. The asymptotes, if we get, oh, look at that, -1 and 2. So I'm going to draw the asymptotes in blue again. -1. When you draw them with your pencil, you're going to draw them with dotted lines. -1 and 2. And, okay, and so, oh, what about the horizontal asymptotes? We can't really see where those are. I mean, basically you can see that this thing kind of looks like this, and like this, but it looks like there's a horizontal asymptote in there. You see there's like that no man's land there. So where exactly is that? We can see that with the table also. So like, for example, and maybe we want a little bit more detail. So we're going to go down here, we're going to make the step size bigger, like we're going to make the step size 0.2 maybe. Oh, that's better. Where did my asymptote go? There it is. So -1. So like I can see that it starts like here it's going to be like a huge number, and then it's getting smaller, and then smaller, and smaller, and it gets to about 3. It looks like 1,3 is about the smallest it gets. And then it goes back to infinity. So like, if you were going to draw this, then the smallest, the minimum point would be 1,3, which would be that point, right? And then here it would go up, and here it would go up. Okay? And then what about if we go to infinity and beyond here? And I'm going to change the step size back. So I'm going to change this to plus 1. Make sure when you do it on a whole number. Otherwise, you're really going to mess up your calculator. Oh, I didn't want to do that. Yeah, that's what I want. Okay. So I'm going out to infinity and beyond here, negative infinity and beyond, and I'm getting very close to 0, and I'm approaching it from the bottom. Okay? And what about when I go to the right side, when I go to big positive numbers? If I go to big positive numbers, I don't know where I'm gonna, I'm approaching also 0, but I'm approaching this time, am I approaching 0? Yeah, 0.3. Oh, so one of my critical points is 3, 0. So that's right there, right? 3, 0. My sketch was not bad. And then I'm approaching. Ooh, weird. Look at that. I go up a little bit. And then do I go back down again? So I'm actually approaching 0 from the top. Yeah, it's kind of hard to see that level of detail on the graph. We could zoom a little bit more. And I still can't see it. Okay, but so we could see from the table that it does like go up a little bit and come down. And like if you want to see exactly what the maximum is, then again you could use second Calc Max and look at that. Okay, last one, which is M. And you know, these are complicated functions on purpose because they want to make it look like they want to make functions that you really need the calculator or a computer to graph Although, given enough time, you could make pretty good sketches of these even by hand. And it's just that, you know, in the IB exam, you only have about 6 minutes per problem. So they're not gonna give you really complicated non-calculator graphs to do, because it's kind of a bad way to spend your time. It doesn't show that much math knowledge. So we can see that this last one is going to be like this. It looks like there's an asymptote at maybe at x equals 0, but let's just make sure here. Yeah, at x equals 0, so I'm going to use my blue line to represent the asymptote. Looks kind of like that. Now, is there a number that it does not? On the y, look at that. It's like the smallest it seems to go to is -2 and 2. I'm going to make my step size bigger, like smaller, like 0.1, to see if that's really true. Let's see, what's the smallest it goes to here? -2, yeah. -1, -2 seems to be like the smallest it goes to. So I'm going to adjust my drawing here. So like I seem to have like kind of an asymptote here at -2, -1, -2. I can like mark that point there. And then like, what about on the right side? Is there a similar? Yeah, so 1, 2 is the minimum of this one. So I'm gonna draw another asymptote. Oops, I want to draw my asymptotes in blue. Blue. And then 1, 2. This isn't really an asymptote because it actually touches. I'm just trying to show the range. The range, you can see of this function, it does not go through that. So if we were going to write the range, we would write something like, y is greater than or equal to 2, y is less than or equal to 2. Okay? That would be the range. Okay? Don't write something like, oh, I'm sorry, this is -2, right? Yeah. Don't write something like this. Don't write that, okay? That is a sign that you're not really good at math, because like, look, y cannot be greater than 2 and less than -2 at the same time. And when you write it all in one sentence, that's what you're saying. So don't say that.